we are doing pre-medical examination, competitive exams questions which were asked in 2015. Okay, so we are doing second part of electrostatics. The next question here you are seeing is, two small spherical shells A and B are given positive charges of 9 coulomb and 4 coulomb respectively. 9 coulomb and 4 coulomb. Okay, and placed such that their centers are separated by 10 meter. Center to center, this is 10 meter. Okay, then if P is a point in between them where the electric field intensity is 0, somewhere here there is a point P such that electric field at this point is 0. Okay, you can see that, you can read that. Then, what is the distance of point P from center of A? From center of A. This is A, this is B, and we have to find out this distance. P is such a point where electric field is 0. What is this distance from A? And there are 4 options given to you, and these options are 5 meter, 6 meter, 7 meter, 8 meter and 4 meter. 5 options are there and we are supposed to find out one. Okay, now let us solve it. This x we have to find, and here electric field is 0. This is charge, this is charge. Now, what is test for us? Do you know relation between charge and electric field? Number 1. Question number 2. If there are more than one charge, if there are 2 charges, 3 charges, 4 charges, then how do we find electric field at one point? These are the 2 questions which you must know. Okay, the first thing is relation for electric field at a point due to a charge is given by E is equal to 1 upon 4 pi epsilon naught Q upon R square. This is known to us, relation between E and Q. The second thing, this Q is making an electric field, this Q is making an electric field. Then what will be the total electric field there? Will it be an ordinary sum? Answer, no, it will not be an ordinary sum, it will be a vector sum. Okay, that means we have to take it along with direction. So here, no negative charge is there, both are positive. So this positive charge will make electric field here by repulsion. This is the direction of electric field created by this, and this is the electric field created by this. This will make electric field in this direction, this will make electric field in this direction. Let us call this is E by A and this is E by B. Now, we want that the electric field should be 0. Now, how to get this electric field to be 0? So, electric field due to A. Electric field due to A is 1 upon 4 pi epsilon naught Q upon R square 1 upon 4 pi epsilon naught. How much is the Q? Q here is 9 coulomb, 9. How much is R? R for this is X. 10 मीटर टोटल है यहाँ से यहाँ तक और यहाँ से यहाँ तक x है, तो हम यहाँ से ये पॉइंट x डिस्टेंस पर है, so this is x square. Okay, the direction is positive, so we will write it positive. Now, E due to B is equal to 1 upon 4 pi epsilon naught Q upon R square. Again we put the value here, Q is equal to 4 and this distance, this total is 10, 10 में से x को minus करिए and this will be 10 minus x. So, this is 10 minus x square. And this direction is on this direction, so this is negative. Now either we add the two and make it equal to 0. जब हम इन दोनों को ऐड करके 0 करेंगे, एक प्लस होगा और एक माइनस होगा. सो ये दोनों 0 कब होंगे? जब ये क्वांटिटी इस क्वांटिटी के इक्वल हो जाएगी. तो एक स्टेप हम आगे चले जाते हैं एंड वी विल राइट देम इक्वल. सो 1 अपॉन 4 पाई एप्सिलॉन नॉट 9 अपॉन x स्क्वायर इज इक्वल टू 1 upon 4 pi epsilon naught 4 upon 10 minus x square, and this is cancelled. Take x square on this side, so this will be x square upon 10 minus x square. This is equal to 9 upon 4. Take square root of both the sides, and this will be x upon 10 minus x, and this is equal to 3 upon 2. So plus minus, because we are taking square root. Okay, let's first take positive value. So this will be 2x is equal to 30 minus 3x. And that will be 5x is equal to 30, so x is equal to 6 centimeter. Okay, this is when we have taken this equal to positive. If we take it negative, then this is minus 2x, so this will be minus 2x is equal to 30 minus 3x. And now you will find it, x is equal to 30. So x is equal to 30 will be outside this line, so we reject this, because in our question what is given, at which point between the two. So we reject this and our answer comes to be x is equal to 6 meter. Now please see the answer here, and what we find that answer B is our correct option. So B is our correct option. Okay, this question reads, a point charge Q, small q, is situated at a distance r on the axis from one end of a thin conducting rod of length capital L. Here, a thin rod, it has a length L. From one end there is a distance r, and here on the axis, this is axis, at distance r, here charge q, small q, is located at this point. Okay, now there is a charge capital Q which is distributed all over this length. You have seen this? Okay, now we are supposed to find out the magnitude of electric force between the two, this charge and this charge. What is the force between these two charges? This we are supposed to find out. Now, what we have studied, that force between two charges is given by Coulomb's law, and the Coulomb's law, in that we will not make Q multiplied by Q. Why we cannot make? Because remember, this is your test, that Coulomb's law is only for point charges and not for distribution of charges. If the charge is distributed over a sphere, over an area, then there are certain modification in our formula and we do the derivation for that. So here again, we are supposed to do the derivations because this is distributed. See, from this charge, the distance is r, and from this charge, how much is the distance? Answer, this distance is r plus L. R plus L. So, this makes a different type of force. This makes a different magnitude of force. So, the total force will be how much? Can we take the average? No. We have a method, and that is we will take the help of Coulomb's law and calculus. How we do that? There is a very standard format for doing that, and we have been doing it in all the calculations. That is, first we will take a point charge here. How do we take a point charge here? Let us take one charge here, point charge. So we make a very small length here, and that small length we will call dx, and this point from here is at a distance of x. This is the method. From this point, the distance is any distance, that is x, and this is a very thin layer, just like a point, that is dx. How much will be charge on this? The answer, the charge on this will be dq. Very small charge. And this is a point charge, we can say, because dx is very small. So how much is this point charge? This is linear charge density q divided by L, charge per unit length, and how much length we are taking? Dx. So this is very small charge, q upon L multiplied by dx. Now we can say this is a point charge. If this is a point charge, now we can apply Coulomb's law here, and let us start. So at distance x, how much will be the force between the two? A very small force due to the small charge is equal to 1 upon 4 pi epsilon naught dq into q upon square of the distance x square. Okay. Now this will lead to 1 upon 4 pi epsilon naught. This dq we would like to convert into function of x. So how much is this dq is equal to? Q upon L into dx. Q upon L into dx. This is x square. This is q. Okay, this is the small force due to these 2 point charges using Coulomb's law. Here we can apply the Coulomb's law. Now, how do we take the total from this point to this point? So this point, and we know the answer is doing integration of all these forces. So we are doing integration of this df. So that will give us f. Okay, so integration of ds will be integration of this. So out of this, which is the variable quantity, from here to here, what is changing? Answer, x is changing. So x is the variable quantity, and this is not changing, not changing, not changing, not changing. All these are constants. So we will have an integration of dx upon x square. This upon x square, I can write it as x to the power minus 2. So this is x to the power minus 2 dx. This will be integrated, and rest all will be constant. 1 upon 4 pi epsilon naught q upon L. Now, if we are doing integration, then what are the limits of x for which we are doing the integration? Answer, x start from here. What is the value of x at this point? R. So this will start integrating from R. Okay, then where will it go? Answer, it will go up to R plus L. So this will start from R and go up to R plus L. So these are our 2 limits for which we have to do the. So it is starting from integration. यहाँ से लेके यहाँ तक करना, and how much is this distance? This distance is R plus L from here to here. So this is integration, and we will start integrating it from smaller value R. Okay, now let's go for this integration, and you know it. This is equal to QQ upon 4 pi epsilon naught into L, and this will be x to the power minus 2, minus 2. Now when we integrate it, this will become x to the power minus 2 plus 1, that is minus 1, divided by minus 1. Integration is done. And what are the limits for this? R and R plus L. Okay, this is equal to Q upon 4 pi epsilon naught L. Inside, first, minus 1 upon x, 1 upon R plus L, minus of minus, plus 1 upon x की जगह पे R लिखा, so this is R. So this is equal to Q upon 4 pi epsilon naught L, and this will be plus minus R plus L. This is LCM, and this will be minus R, and this will be plus R plus L. Okay, so this is equal to cancelled, and here we have L upon R into R plus L. So we write it Q L upon 4 pi epsilon naught L R into R plus L. And here we cancel out this L, and we get Q upon 4 pi epsilon naught R into R plus L. Okay, now many options are given to us. Please see the options. They have used the letter K for Coulomb's constant. What is that Coulomb's constant? 1 upon 4 pi epsilon naught. So this we can write as K Q upon R into R plus L. Okay, and now you can match it. You can see that this is matching with D. So our right option is D. Okay, so this is done. Please see this. What we have done, we have to apply Coulomb's law only between the point charges, because this is a distribution of charge. First, we consider a point charge by taking a small length dx at a distance x. So we make a formula of x with a point charge dq, which is a function of x. So here we find the force, then integrate it, applying the limits of x. X changes from R plus R, R plus L to R. So we get this answer in this way. The distance of the closest approach of an alpha particle fired at nucleus with kinetic energy K is R naught. Here is the nucleus. Nucleus is positively charged, and we are firing an alpha particle. Here the alpha particle goes and returns from here. This distance is known as the distance of closest approach, D, and they say this, in this example, this is equal to R naught. Again, I read it. The distance of closest approach of an alpha particle fired at a nucleus with kinetic energy K. This alpha particle has kinetic energy equal to K. Okay, it is written there. Now, okay, this is R naught. The distance of the closest approach when alpha particle is fired at the same nucleus with the kinetic energy 2K. In second case, we are sending this alpha particle and we are giving it a higher speed, and that speed, the kinetic energy increase, and this kinetic energy, which was K, now it is equal to 2K. kinetic energy has become 2k. How we increase the kinetic energy? We increase the speed. Okay, so this is 2k and this alpha particle goes up to further distance and then again it is returned back. But this distance of the closest approach, this is now again changed. And let us say this distance is now x. And this is our answer. This is our answer. Please see what is written. The particle is fired at the same nucleus with kinetic energy 2k and the distance of closest approach will be, here are the four options, that is 4 r0, r0 upon 2, r0 upon 4, 2 r0. We have to find any one of them. Okay, so let us find out this x. Okay, now what happens here? Answer again, there is a force of repulsion. Okay, because of repulsion, there is a distance, there is a force of repulsion, there is kinetic energy, and this kinetic energy, remember, it has got a speed. Because of this force, there is a retardation. इधर से फोर्स लगा, स्पीड कम होते गई. जब यहाँ पर ये पार्टिकल पहुँचता है तो स्पीड क्या हो गई? 0. If the speed has become 0, then how much is kinetic energy here? 0. If the kinetic energy is 0, where that kinetic energy has gone? Answer, that kinetic energy has been converted into potential energy. Okay, so that kinetic energy is converted into potential energy. So how much is that potential energy? Answer, that potential energy is K, because that was the amount of kinetic energy. So what is the relation between R0 and kinetic energy? Do we know something? Answer, yes, we know something. There is certain charge of the alpha particle. We know there may be any charge. Let us say this has got charge Q. So in this is also having charge Q. This is having charge Q. This is also having charge Q. We don't need to go for exact values because we are after R0, X and kinetic energy. So this kinetic energy at this point is converted into potential energy. These are the 2 points. It has got charge Q, this has got charge Q, there is a distance R0. Then what is the formula of potential energy between the 2 charges? See, the question is speaking about kinetic energy, but what we are supposed to find out? Potential energy. Why? ये सीक्वेंस हमको याद होनी चाहिए कि जब अल्फा पार्टिकल यहाँ जाता है तो इसकी स्पीड 0 हो जाएगी and all the kinetic energy is converted into potential energy. And this is what is supposed to know in competitive exams. तो question electrostatics का है, but all this knowledge is used that when speed becomes 0, the kinetic energy converts into potential energy. And we know the formula for potential energy in electrostatics. We don't know the formula of kinetic energy. So, what is the potential energy here? Answer is potential energy K is equal to 1 upon 4 pi epsilon naught charge 1 multiplied by charge 2 upon distance. Not square, only power 1. You remember? This is potential energy. Q upon R0. So this is from your knowledge which you are supposed to remember. ये आपको अगर याद नहीं है तो आप ये क्वेश्चन अटेम्प्ट नहीं कर सकते, इसलिए फॉर्मूला याद करना जरूरी है. ये हो गया. अब सेकंड केस में देखिए. सेकंड केस में यहाँ पोटेंशियल एनर्जी में कौन कन्वर्ट हुआ? 2k. तो यहाँ फॉर्मूला क्या बना? 2k is equal to 1 upon 4 pi epsilon naught and Q, same alpha particle, Q, same nucleus, the distance is x. So this is equation 1 and this is equation 2. Now it is a very small thing. You have to find the value of x. So divide. If you divide this by this, what you get? 1 upon 2 is equal to x upon R0. Okay, so x is equal to r naught upon 2. So this is the value of x we get here. So you have got many options here. Now look for the options, which is r naught upon 2, and you will find here it is given. This is option number B. So our right answer is B, r naught by 2. यहाँ पर आपका क्या टेस्ट है? नंबर 1, आपको ये याद है कि नहीं कि काइनेटिक एनर्जी चलते हुए चार्ज पार्टिकल में जब वो पार्टिकल रुक जाएगा, दैट इज कन्वर्टेड इनटू पोटेंशियल एनर्जी. नंबर 1. नंबर 2, आपको ये याद रहना चाहिए कि चार्जेस के बीच पोटेंशियल एनर्जी का फॉर्मूला क्या होता है और उसमें ये स्क्वायर नहीं होता है. दिस इज पावर 1. ये दूसरी चीज याद रहेगी आपको. और तीसरी चीज, देन इट इज ए प्रोसीजर. 2 सिचुएशन दी है, इसलिए हमने 2 बार इक्वेशन लिख लिया और 2 बार इक्वेशन लिख के now it is a child's play. You can always ask in Gujarat CET. I don't know how easy questions they are asking, but it's a very simple question. One line, you can do it orally. See, when 10 to the power 19 electrons are removed from a neutral metal through some process, the charge on it become. What is the charge which will become of that metal? Okay, so what are the quantities involved and what is asked from us? The answer is, what they are asking is charge. What is given to us? Number of electrons. That is given to us 10 to the power 19. And our knowledge says we know the charge on one electron, that is E, is 1.6 into 10 to the power minus 19. That is also known to us. Q and E. Does it ring some bell? Yes. We all know that Q and E, this is the famous formula of quantization. And this quantization is what? The charge on any metal, the charge on any body, Q is equal to number of electrons either given to it or taken out from it, and the relation is Q is equal to NE. So the question said that electrons are taken out. If the electrons are taken out, what charge will develop? Answer: electrons, negative charge is taken out, so the charge will be developed as plus. So we will use only plus. So now it has become very easy. 10 to the power 19 into 1.6 into 10 to the power minus 19. So this is 1.6, and what should be its unit? The answer is, we are working in SI units. This is coulomb. So this will be coulomb. So how much will be charged on that metal? Answer: 1.6 coulomb. And now you can check the answers. 1.6 coulomb. There are two 1.6 coulomb. Out of that, which one you will choose? We have already decided it is positive. So plus 1.6 coulomb, that is option number A, is our right answer. You see, so competitive means you must study each and everything. It is a very preliminary, very first formula, but it has appeared in a PMT examination. This says a charge Q is uniformly distributed over a large plastic plate. Mind the word, uniformly distributed. There is a large plastic sheet and it is uniformly distributed. At a certain point here. So it says that, okay, at a certain point P close to the center of the plate, the electric field is 10 volt per meter. 10 volt per meter near center. Okay. Now this plate is replaced by a copper sheet. and the same charge Q is given to that copper sheet. What will be the electric field at this point? Now, इस क्वेश्चन में कैलकुलेशन कुछ नहीं है, ओनली हमारे कंसेप्ट का टेस्ट है. वी नो दैट ए लार्ज शीट ऑफ प्लास्टिक इज ए बैड कंडक्टर एंड कॉपर शीट इज ए गुड कंडक्टर. और हमको इस क्वेश्चन में ये कंफ्यूज करने की कोशिश की गई है कि अगर हम एक बैड कंडक्टर से एक गुड कंडक्टर को रिप्लेस करें तो क्या इलेक्ट्रिक फील्ड में कोई चेंज आएगा, और इन्होंने 4 आंसर दिए. लेकिन हमको ये याद रखना है कि इलेक्ट्रिक फील्ड चार्ज पार्टिकल से बनता है. उसको कंडक्टर का चार्ज पार्टिकल है या नॉन कंडक्टर का चार्ज पार्टिकल है, उससे कोई फर्क नहीं पड़ता. कॉपर में जब हम चार्ज देते हैं तो कॉपर का चार्ज इक्वली डिस्ट्रीब्यूट हो जाएगा. प्लास्टिक में जब हम चार्ज देते हैं तो वो चार्ज इक्वली डिस्ट्रीब्यूट अपने आप नहीं होता, वो एक पॉइंट चार्ज ही रहेगा. ये यहां अगर हमने चार्ज दिया तो पूरा चार्ज यहां हो जाएगा. लेकिन इस क्वेश्चन में, इन पर्टिकुलर दिस क्वेश्चन, इन द फर्स्ट सेंटेंस दे हैव रिटन व्हाट? Equally distributed. That means here it is equally distributed. अब ये अगर कॉपर है, कॉपर बिकॉज इट इज ए गुड कंडक्टर, इसको कहीं भी चार्ज देंगे ये अपने आप इक्वली डिस्ट्रीब्यूट कर लेगा. इक्वली डिस्ट्रीब्यूटेड. और प्लास्टिक में we have done equal distribution. अगर हमने इसमें इक्वल डिस्ट्रीब्यूशन कर दिया है तो ये और ये दोनों एक जैसा बिहेव करेंगे. ये भी चार्ज की एक शीट है, ये भी चार्ज की एक शीट है. इसलिए जो पोटेंशियल, जो इलेक्ट्रिक फील्ड इसने बनाया वही इलेक्ट्रिक फील्ड इसमें बनेगा. एंड फॉर योर रेफरेंस हमको मालूम है कि ये इलेक्ट्रिक फील्ड कितना होता है. दिस इज सिग्मा अपॉन 2 एप्सिलॉन नॉट. एंड दिस इज फॉर फॉर्मूला फॉर व्हाट? ए शीट ऑफ चार्ज. अब ये भी एक शीट ऑफ चार्ज है, ये भी एक शीट ऑफ चार्ज है. इट हार्डली मैटर्स कि ये कॉपर है या प्लास्टिक है. अंडरस्टैंड? चेंज कब होता? अगर हमको ये कहते कि प्लास्टिक शीट को हमने एक पॉइंट पर क्यू चार्ज दिया, प्लास्टिक शीट अपने आप नहीं फैलाएगी उसको. और तब हम यहाँ कौन सा फॉर्मूला लगाते? हम यहाँ फॉर्मूला लगाते Q अपॉन आर स्क्वायर का. पर वो केस नहीं है. इन्होंने कौन से शब्द उसमें लगा दिए, कौन से वर्ड इंसर्ट कर दिए? इक्वली डिस्ट्रीब्यूटेड. सो दिस हैज बिकम इक्विवेलेंट टू कॉपर. एंड नाउ this is applicable for this as well as this. So what will be our answer? Our answer will be same, 10 volt per meter, and there will be no change, and we have this answer C. C is same value, and that is our answer. Ratio of dimensions of electromotive force to magnetomotive force is equal to option 1, 2, 3 and 4. We have to find out. Okay. Now, what is this electromotive force and magnetomotive force? Electromagnetic force, EMF, voltage. We have the dimensions of voltage equal to, that is, you have known dV upon dr is equal to E, or dV upon dl is equal to E. So we know that V has the dimensions of E dl. We can say electromotive force is equal to integration of E dl. Okay, this is electromotive force. Now, what is magnetomotive force? Magnetomotive force F, magnetomotive. This was electromotive, the one which is moving the electrons. Okay. The one which is moving the magnetic pole, that force is equal to, in the place of electric field, we will have magnetic field intensity, and this will be dl. This is magnetomotive force. The magnetomotive force will move the magnetic dipole, magnetic pole. Okay. Now, the question is asking what is the ratio of dimensions of the two. Okay, ratio. We take the ratio. Ratio is E EMF divided by magnetic force is equal to electric field divided by magnetic field. So, electric field divided by magnetic field. From our knowledge, this is our test. Whether we know what is E upon H equal to. The answer is electric field divided by magnetic field. This is having the dimensions of impedance. Impedance. And what is impedance basically? Impedance has got unit ohm. Resistance is also having unit ohm. So what are our options here? See, the dimensions of magnetic field, dimensions of electric field, dimensions of resistance, and dimensionless. The answer is it is not dimensionless, and it has got the same dimension as the dimensions of resistance. So the answer will be the ratio of the two forces will have the dimensions of resistance. Okay, so this was something new in addition to our CBSE syllabus. So you can remember it. This says a uniform electric field is created between two parallel charge plates as shown in the diagram. There is a uniform electric field created between the two charged plates, and these plates are charged, the positive charge here and negative charge here. Okay, these are the two plates. Uniform electric field, everywhere value is same. Now, they say an electron enters the field symmetrically between the plates with a speed of V0. One electron enters here. This electron has got charge which is equal to E. It has got mass equal to M, and it enters here symmetrically. इसके बीच में आएगा, and it has got certain speed. Okay, it is given to us with a speed of V0. Speed V0. Okay, so this electron enters. The length of each plate is L. The length of each plate is L. This distance is L. Okay, then after that, find the angle of deviation of path of the electron as it comes out of the field. Okay, यहाँ से ये इलेक्ट्रॉन सीधा जाता है. Angle of deviation from its path. क्या ये अपने पाथ को छोड़ के मुड़ जाता है? तभी तो एंगल आएगा. आंसर इज यस. तो ये यहाँ से जाता है और निगेटिव चार्ज के कारण प्लस इसको अट्रैक्ट करेगा. सो देयर इज ऑलवेज ए फोर्स एक्टिंग अपवर्ड. दिस नेगेटिव विल रिपेल, प्लस विल अट्रैक्ट. सो देयर विल बी ए फोर्स एक्टिंग opposite to the electric field. This is the electric field direction, E. And force on electron is opposite to the electric field towards positive charges. So a force is acting on it. What will happen due to the force? The force will create an acceleration, and due to acceleration in this direction, the electron will start drifting in this direction. So this will start drifting like this, and it will come out here. So the question is, this was its original direction, and this, after it comes from here, it goes like this. So what is this angle we are supposed to find out? You see what was given in the question, what was the deviation from its direction. So this is the deviation from the direction which we are supposed to find out. So how can we find it out? See, this is a particular direction it has achieved. Do you remember any such thing you might have seen? The answer is yes. It is a projectile motion, inverted. There is a horizontal speed v0 in this direction. Is there any acceleration in this or in this direction? Answer no. Acceleration is only in this direction. So if there is no acceleration in this direction, will there be any change in this velocity? No. The answer is there is no change in this velocity. So at every point, this velocity remains in this direction, v0. Okay. Then what happens because of this force? The answer, a velocity is developed in vertical direction because of this acceleration. How much is that velocity? Suppose that velocity is v0. That velocity is v dash or v vertical. Now, if this is the v vertical velocity, this is horizontal velocity, then where is the resultant velocity? This is the resultant velocity. And once we know this diagram, how much is this, how much is this, that is, how much is this, then we can always find out this angle. This angle is theta. This is deviation from the horizontal path, and this theta will be given to us by the equation tangent of theta is equal to this v dash. What is that? Vertical, v horizontal. We have to find values of these two, and this value we know it is how much? v0. So now what we have to calculate? Only v vertical. We have to find out how much will be the velocity here. How do we find it? Okay, it is a very simple question of kinematics. How? This is experiencing an acceleration in upward direction. Then what is the change in velocity? The answer is final velocity v is always equal to u plus at. Yes. Okay. Do we know vertical velocity, initial velocity? Yes. U in vertical direction. Initial velocity in vertical direction was not there. So its value was 0. Because all the velocity was horizontal. So u vertical was 0. Now, acceleration. Acceleration is force upon mass. Acceleration is force upon mass. What is the force on electron? If electron having charge E is kept in electric field E, then the force is E into E. Okay, charge, we know that force is equal to Q into electric field. So this is the force, and this is to be divided by mass of the electron, and this is acceleration. We will not write minus or plus because we know the direction. The acceleration is upward. Okay, this is acceleration. This. Now, T. How much, for how much time this has been under its impression? Answer, till it is out from the electric field. इलेक्ट्रिक फील्ड को पार करने में जितना टाइम लगा उतनी देर तक इस पर एक्सेलरेशन लगता रहा, तो वो टाइम कैसे निकालेंगे? तो आंसर है ये टाइम निकालने में हमको ये हेल्प करेगी. टाइम तो चाहिए हमको, तो टाइम हम कैसा निकालते हैं? यहाँ पर हॉरिजॉन्टल वेलोसिटी v0 है और हॉरिजॉन्टल डिस्टेंस कितना है? l. और ये जब यहाँ पहुंचता है तो इससे हॉरिजॉन्टल डिस्टेंस कितना ट्रेवल कर लिया है L, और किस वेलोसिटी से ट्रेवल किया है v नॉट. सो व्हाट इज द टाइम? टाइम ऑफ फ्लाइट is equal to distance L upon velocity v naught. This is the time. So T is equal to L upon v naught. Now we can get the final velocity in vertical direction. So how much is that? Let's calculate. Final velocity in vertical direction is 0 plus a E upon m into T L upon v naught. This is the vertical velocity at this point. And now we come back to our original understanding that tan theta is equal to what? V vertical divided by V horizontal. And you got it. Yes. Tan theta is equal to V vertical, V horizontal, and V vertical is E L upon mv naught. This is to be divided by V horizontal, and V horizontal is V naught. V naught. So we get here E L upon m V naught square. So this is tan theta. And now you can check your answer. Theta is tan inverse E L m V naught square. And here you will find, please check here, is there any answer of that? E L upon m V naught square, and that is answer number B. So this is our correct option, answer number B. So this is a beautiful question. We have the projectile motion, we have the force on charge, and all these put together along with kinematics. This is a real competitive examination questions. So you will find there is a combination of questions, difficulties. Sometimes it's very easy. The earlier one was Q is equal to NE. And sometimes it has got certain difficulty level of this. It says a battery charges a parallel plate capacitor, okay, with the distance d, so that energy V naught is stored in the system. This is a capacitor. It has got this distance d, and this we connect with a battery. When we connect with a battery, then the charges goes here, and along with the charges, energy is transferred to this. Okay, the voltage of this becomes V naught. It has a capacitance C. Okay, now the next thing it says is a parallel plate capacitor. Okay, a battery charge a parallel plate capacitor of the distance d, so that energy V naught is stored in the system. A slab of dielectric constant K and thickness d is then introduced between the plates of capacitor. The new energy of the system is given by. Okay, so I will request you to see the situation of battery. Is the battery removed or battery is not removed? See it again. A battery charges parallel plate capacitor. Okay, a slab is then introduced between the plates. There is no reference that battery has been disconnected. That means battery remain connected. And this is your crucial point. We have done in a question earlier. We must see whether when passing the dielectric slab here, the battery remains connected or disconnected. So in this case, it remains connected. And we put a dielectric slab here. It has got dielectric constant K. Thickness is total D. Okay. Now, what will be the new energy of the system? What was the energy earlier? Answer, this is energy, not voltage. So let's write it energy. This was the energy earlier. Initial energy. And they say that final energy will be out of these four. Okay? So we have to find out whether final energy will increase or will it decrease. If it increase, then there will be a multiplication of K. If it is decreased, then there will be a division of K. Okay? We will find it out. Now, what happens when we put a slab in the capacitor? Answer, whenever we put a slab in the capacitor, then one thing is compulsory, that capacitance increase. And how much is the new capacitance? That is always K times C. Okay. Now, this capacitance has increased. This is compulsory. What is the effect of battery which remains connected? The answer is, if the battery remain connected, then its potential cannot decrease. Potential cannot decrease or increase. Nothing. So, V is constant. So now we know C dash has changed, it has increased, and V is constant. Do we know any formula of energy which is having C as well as V? Everybody knows it. So, energy before putting the plate is half C V square. Okay, this was the energy before, and how much is that? V naught. I will write it to avoid the confusion. Let me write it CE. This is EMF. Okay, so CE square is equal to V naught. Energy after insertion, half C. Now this C has changed. This is how much is that C now? So this is half C dash. The voltage has not changed. E square. So this we can write energy after insertion. So this is equal to half C dash is equal to KC. E square. So half K, and this half, I will write it half C E square into K, and see this half C E square. Let us say this is the new energy, new, N. So divide the two. If we divide the two, then V new upon V naught original, energy new divided by energy original, this divided by this, so half C square K upon half C square is equal to K. So V new is equal to K times V original. So do we have an option here? The answer is yes. We have an option, and that is option number 1. 1 says that new energy is equal to K times original energy. So this is how we do it. So once again, remember, when battery remain connected, V is constant, and whenever we put a slab, it is compulsory that capacitance will increase. So with this, we have seen that 2 boards have asked. There are more of these questions. This is a very popular format of the question. In this question, the diagram says there is a sheet which is seen from this side. Okay, this is a sheet which has been charged here, uniformly charged. Now I make the drawing like this and put another charged particle here, and that is tied with a string. What happens that earlier the string was like this, and when I charge it, there is a repulsion. This is also charged, so there is a repulsion between the two, and it goes in this direction. But when it goes in this direction, there is a tension in the string, so it cannot go far away. It cannot go here. Why it cannot go there? Because mass is attracted by the ground, and there is a force mg acting downward. There is a force of repulsion on this, and that force is in this direction. This is electrical force, Coulomb's force. So this force is repelling it in this direction, and this mg is attracting in this direction. This is sheet like this, and because of these two forces, there is a resultant, and that resultant is in this direction. If that resultant is in this direction, then it comes to this direction, it develops a tension here, and this tension balances this resultant force. So now at this point of equilibrium, it is neither going in this direction nor it is coming in this direction, because resultant of the two has been balanced by T. This is the situation. If this is the situation, then they are asking us that what is this angle theta? And what are the given quantities? The answer AA dash is surface. Then, okay, this point is kept in a perpendicular direction. Then this has a surface charge density sigma. Okay, and the next thing given to us is this has got mass m, the gravity g. Okay, the charge on this particle is q. Charge on the particle is q, mass of this particle is m, the charge density here is sigma, and it makes an angle theta. Okay, now the tangent of angle theta is how much? We have to find out tangent theta, and what will be the probable answer of this tangent theta. So this is very clear. You have done this many questions in laws of motion, free body diagram. So let us see the diagram of this body. In this body, this is in equilibrium, and when it is in equilibrium, then sum of all the forces is 0. Or the forces in any one line, the sum is 0. So to make equations, we make two parts of this tension, and one is this. If this angle is theta, then this angle will also be theta, alternate angles between two parallel lines. So if this is theta, this component will be t cos theta. So we have resolved this t. The vertical component is t cos theta, and this horizontal component will be t sin theta. And now we have the equations here. T sin theta is equal to electrical force, and t cos theta is gravitational force, that is mg. And this electrical force, you all know, electrical force is equal to what? Electrical force is equal to the charge here, Q. Charge Q multiplied by electric field. This formula, ये आपको याद होना चाहिए, ये आपका एक टेस्ट. दूसरा टेस्ट, क्या आपको याद है कि शीट के कारण यहाँ इलेक्ट्रिक फील्ड कितना होता है? तो किसी भी पैरेलल शीट के कारण इलेक्ट्रिक फील्ड का फॉर्मूला फिर से याद करिए. दिस इज सिग्मा अपॉन 2 एप्सिलॉन नॉट. तो ये क्या आ गया? इलेक्ट्रिकल फोर्स. वी विल पुट इट हियर. and this will become Q sigma upon 2 epsilon naught. Divide the two and we get tangent theta, and tangent theta is equal to Q sigma upon 2 mg epsilon naught. This is tangent, and now you can see Q sigma upon 2 mg epsilon naught. 2 mg epsilon naught. Yes, that is option number A. No other one matches here. So for the force, don't apply 1 upon 4 pi epsilon naught. Otherwise answer will come, that is also there with pi. So remember, this is how it is done. You should remember that electric field due to plane surface is sigma upon 2 epsilon naught. And the formula for force is to be used Q into E, not Q1, Q2 upon R square, because there is no point charge here. There is a distribution of charges, so we cannot use that formula Q1, Q2 upon R square. We can use formula Q into E and put the value of electric field. So that force, this force, keep it in this direction, and you have done many questions like this in pendulum also, in charges also. Okay, so this is with the time constant. It says a capacitor of capacitance 100 microfarad is charged by connecting it to a battery of voltage 12 volt. 100 microfarad. This is connected with a battery of 12 volt. Okay. With internal resistance of 2 ohm. 2 ohm. This is R. Okay. After that, the time after which 99% of the maximum charge is stored on the capacitor. Final charge हमको कितना चाहिए? Q final 99%. And what we are supposed to find out? We are supposed to find out the time after which time of this 99% charge. This is what is asked from here, and there are these 4 options given. Okay. Now, whenever we are charging the capacitor, there is a term known as time constant. How much is that time constant? Can we find out when it goes to that 0.67%? Okay. So, 0.67 of the total value. Okay. Now, what is the time constant in this? In any capacitor, we know time constant. Time constant tau is equal to C into R. So here C has a value 100 10 to the power minus 6 into resistance is equal to 2. So we have it 200 into 10 to the power minus 6. This is time constant. Second, okay, so this is time constant. Now, the Q, what is the maximum value of Q and what is the value of Q at time t? For that we remember the formula. Q at any time t is equal to the full charge CE 1 minus e to the power minus t upon RC, this time constant. This is our formula for charge, and this is what? Full charge. So Q upon CE, how much is that value? Q upon CE, full charge and discharge. How much we need? 99%. So this quantity is equal to 1 minus E, and this is T, the time required to make this charge, divided by RC. What is the value of RC? 200 into 10 to the power minus 6. This. Now, Q upon C is 99%. So this we can write as 0.99 is equal to. This we will take on this side and this we will take on this side. Anyway, we write it here. 1 minus E to the power, this is minus, E to the power minus T upon, this is 2 into 10 to the power minus 4. Okay, so this we take on this side, so this will be 1 minus 0.99, that is 0.01 is equal to, this will be E to the power minus, or E to the power minus T upon 2 into 10 to the power minus 4. This. So now this gives an equation that E to the power this. So here we have, this is 0.01 is equal to, because of this minus we can write it 1 upon E to the power T upon 2 into 10 to the power minus 4. Okay, now cross multiply this, and what do we have here is, that is E to the power T upon 2 into 10 to the power minus 4. This is E to the power minus 4 equal to, this will go here, 1 upon 0.01, and 1 upon 0.01 is 100. Now, this is log natural of 100 is equal to T upon 2 to the power 10 minus 4. And natural log of 100 is 4.605. 4.605 is equal to T upon 2 into 10 to the power minus 4, and here we have T is equal to, this you multiply, 4 to the 8, 9, 9, this is 0.92 into 10 to the power minus 3, that is 0.921 millisecond. This is second, so 0.921 millisecond, and here you will find there is one answer as 0.921 millisecond, that is answer A, 0.92 millisecond. So we have a right option A. Okay, now once again, charge at any time is given by this equation. This is our fundamental knowledge, what we need. This charge is maximum charge, so Q upon CE is 0.99, that is 99%. This is equal to 1 minus E to the power this, and rest is mathematics. So that you can do 1 minus this, and all these natural steps, and you will come to that time required is 0.92 millisecond. So this is what we have done, and now next lecture we will see another time. Thank you.